Okay, so pH maintenance starts at the PCT. So pH in the proximal convoluted tubule. So if this is a cell in the proximal convoluted tubule, out here's the lumen. So the filtrate is there. And then we've got blood down here. So in the proximal convoluted tubule, we know that 70% of nutrients or solutes that were dumped into the Bowman's capsule are going to be reabsorbed here. And that sort of happens with hydrogens and bicarbonate. So most of the bicarbonate is reabsorbed here. And so basically, in the lumen in the luminal edge of these cells, there exists an enzyme here, okay? And this enzyme is called carbonic anhydrase. And we know that carbonic anhydrase is important in that reaction of CO2 to water into carbonic acid and then to hydrogen ions and bicarbonate. So we reabsorb bicarbonate from the lumen by turning it into water and CO2. Okay, so we have this color. So we have bicarbonate in the lumen because it came out into Bowman's capsule, and there is hydrogens as well. So hydrogens here, and they combined utilizing carbonic anhydrase, So they combine here utilizing this enzyme, and we get CO2 and water. Let's make that blue since it is water. So water there. So CO2 and water both diffuse right into the cell. Okay? In the cell, they will also meet up with carbonic anhydrase. And carbonic anhydrase will split them up into, that's not the right color, hydrogen and bicarbonate. Okay, so carbonic anhydrase will go through that reaction and you will end up with hydrogens and bicarbonate. There is a transporter along the basolateral edge . A big giant transporter. Do it like that. And it's a co-transporter. So co-transport. And what that does is that brings the bicarbonate into the blood. But this is a co-transporter, so it's got to bring something in with it. And what it does is it brings sodium with it. And sodium comes from in the luminal edge, there is a transporter that allows for the exchange of hydrogens and sodium. So we have sodium out here, and it will enter into the cell. And see these hydrogens that are being made here? These hydrogens that are being made are going to come back out. And when they come back out, they can be combined with more bicarbonate to make CO2 and H2O, which will go into the cell and then be separated again into bicarbonate and hydrogen, and that goes out into the blood. The bicarbonate is reabsorbed. So with it, then the sodium is also reabsorbed as well. So the co-transport is sodium and bicarbonate going into the blood. And this occurs at the PCT again. So at the PCT, we're not really in an acidic or an alkalosis situation. The PCT is just basically taking all those solutes that were dumped out and reabsorbing them. So part of that is bicarbonate. We're reabsorbing like a pound of baking soda per day at the proximal convoluted tubule. So there's not really any, oh, we're too acidic, so we're bringing in the bicarbonate to make the blood more basic, and we're getting, just rearranging the hydrogens to make the bicarbonate to make it more basic. But that's not really what's happening. We're just reabsorbing bicarbonate here, basically. Okay. So the next video, we're going to talk about the distal convoluted tubule and the collecting duct, and that is where the fine-tuning of the urine is, and that is where we actually are able to counter acidic and alkalosis conditions.